The heart and soul of Algebra 2 is the idea, the concept of a function. So today we're going to define a function and look at how we can evaluate functions. Basically, a function is any operation that has at most, that's an important phrase, at most one output for any input. In other words, if I pick any value for x, I will always get the same value for y. So if I plug 3 in for x, the answer will always be the same for 3. Now if I plug 4 in for x, I might get a different answer. But every time I plug 4 in, I'll get the same output for that number 4. I like to think about functions as a big machine where stuff goes in one end and out the other end. So for example, this 3 is going into the function machine here, and something happens to it and it comes out as a 4. We can think about the inputs, the things that go into the function, as x's, and the outputs, the things that come out of the function, are the y's. And you'll notice in our function notation, we see the f of 3. That's how we read that. That's not f times 3. It's read f of 3. F of 3 means 3 went inside the function, and the 4 is what came out of the function. So 4 is the y value when the x value, what's inside the function, is 3. And we can plug all sorts of numbers in. Hypothetically, if we plug 2 in, f of 2 might come out to be 3. If we plug -5 in, f of -5 might come out to be 4. That number inside the parentheses is what went into the function, and what it equals is what came out of the function. So first we're going to look at identifying each of these tables represents some type of relationship between x and y, and we want to know if it is a function. And that means there is at most one output for any input. In other words, on this first equation, when 0 got put in, -1 came out. When 3 got put in, 1 came out. Then they put 3 in again, and 4 came out. Notice we plugged the same number in twice, but got 2 different answers. That is not allowed in a function. We say, no, that is not a function, because we got 2 different answers for the same number. Notice the second example, -2 comes out to -1, +2 comes out to 1, 5 comes out to 1, 9 comes out to 7, and 15 comes out to 11. Every single input, every single x value only had at most one y that correlated with it. Notice we took 2 x's, the 2 and the 5, and both of them got mapped to the 1. That's okay. What we don't want to happen is the same x to have 2 different answers. So this next example, example 2, yes, it is a function. The third example, you'll notice that 0 gets mapped to -1, 3 to 1, 5 to 6, 8 to 7, and 3 to 13. But we've already mapped 3 to a number. 3 goes to 1. It can't also go to 13. It cannot go to 2 different values. And so we say, no, the second table is not a function, because there are 2 outputs for the same input of x. Last example, we see 0 to -3, 2 goes to 3, 4 goes to 5, 9 goes to 8, 14 goes to 3. Every number goes to a unique value. There's no repetition of the x values, so we say yes, this last one is a function, because each x value goes to at most one y value. So that's kind of the idea of a function. Every time you put an x in, you'll get the same answer if you use the same x. So let's look at how we can evaluate a function. What we say is what is inside the function is going to be substituted into the expression. And this is very important, so I'm going to highlight it in yellow here. We always use parentheses when we make our substitution. So for example, we've got this function here that f of x is equal to 3x squared minus 5x plus 1, and we want to find f of -2. What this means is -2 is going to be plugged into the f function. So here's my f function. Wherever there's an x, we're going to plug that -2 in parentheses. So 3 times -2 squared minus 5 times -2 plus 1. And when we do that, we end up with a simple order of operations problem. Simplifying the exponents, -2 squared is 4, minus 5 times -2 plus 1. Next, we do our multiplication. 3 times 4 is 12. -5 times -2 is 10, plus 1. So when we add it all together, we get 23. So we could say f of -2 is equal to 23. So what is in the function just simply means plug it into the expression. We can also combine functions together. They can be added, subtracted, multiplied, or divided. We just need to make sure we always use parentheses to represent each function. So if f of x is this x minus 4, and g of x is x squared minus 16, f plus g simply means we take the f function, which is x minus 4, and add the g function, which is x squared minus 16. Then we clean it up and do some simplifying. When we're adding polynomials in this case, it's just combining like terms. Keeping things in order, we have an x squared, we have a positive x, and -4 and -16 is -20. And now we have f plus g of x. We could even plug a number in. If we had f plus g of 2, we'd plug 2 in for each of those x's, and we'd get a solution. Similarly, we can subtract functions. F minus g of x simply means we take the f function, which is x minus 4, and subtract the g function, which is x squared minus 16. Now we know when we're subtracting functions, we have to distribute that negative through. So that's going to actually be x minus 4 minus x squared. Negative times a negative is plus 16. And now we can combine those like terms of the -4 and the 16. Putting things in order, negative x squared plus x plus 12, -4 plus 16. F times g of x, very similar idea. Notice there's nothing in between them. You might see the solid dot. That's going to be different than an open dot, which we'll talk about in a minute. But f times g of x simply means we take the f of x, which is x minus 4, and multiply by the g of x, which is x squared minus 16. Not much we can do to simplify, but if we felt inspired to FOIL this out, x times x squared is x cubed. Let's do the inside next, which is -4x squared, then -16x, positive 4 times 16 is 64. So we can multiply it out if we wanted to, but either way would be just fine. So you get the idea. We just basically replace each function with what it represents. F over g of x means we take the f of x, which is x minus 4, and put it over the g of x, which is x squared minus 16. Now we have to be careful when we reduce fractions. We can't just cross things off on fractions. That's not allowed. We can divide out common factors, though, and you'll notice that denominator is a difference of squareds, x plus 4 times x minus 4. And now that I do have a common factor of the x minus 4 to divide out, leaving behind a 1 in the numerator, this is 1 over x plus 4. So we can combine fractions by adding, subtracting, multiplying, or dividing them. But there's another thing we can do with functions that's very special to functions, and that's what's called a composition of functions, where we put functions inside of functions. So for example, if I've got f of x equals x squared minus x, and I want to find f of x minus 3. Notice this whole x minus 3 is in parentheses. That's what we're going to use to replace each of the x's, because whatever is inside the function gets plugged into the variable. So f of x is equal to x, which now becomes x minus 3 squared, minus x, which now becomes x minus 3. And then we can do some simplifying. We can square a binomial by squaring the first. Don't forget to take the product, negative 3x and negative 3x twice is negative 6x. Square the last, 3 squared is 9. Distribute that negative through, negative x plus 3. And now we're ready to simplify our final answer. X squared, negative 6x minus x is negative 7x. And 9 and 3 is 12. And now we've got our final function in function. That x minus 3 was inside the function, so we plugged it inside the x's and simplified. Anything inside the function, the variable gets replaced with. Now we have a fancy way to show this exact same process, and that is what we call the composition of functions. This is where you're going to see that open dot. That does not mean multiplication. F of g of x is what that means. Often it's written with f and the g of x is inside of the f. That means we're going to put whatever the g function is into the f function. So what you're saying is we've got functions inside of functions inside of functions. It feels weird, but don't get caught up in the weirdness. Follow the process, and it's actually quite straightforward. If we're going to find f of g of x, that means we've got f of, and the g is inside. Well, g here is x plus 4. That's what it really means, is f of g. What's g? G is x plus 4. Plug that into the f. And just like we did before, whatever's inside the f gets plugged inside the variable, into f in this case. So f is x squared. Well, now it's x plus 4 squared. And then there's that minus 5 at the end. We're not going to lose that. Now all I have to do is simplify this. X squared plus, we got to do the product twice. 4x and 4x is 8x. Plus 4 squared is 16 minus 5. And just a real quick combining of like terms, we're left with x squared plus 8x plus 11. And that's the composition of functions, f of g of x, which simply means put g into f for the variable. We covered a lot in today's video. It's a little bit of a longer video because we introduced a function, we evaluated functions, and we combined functions with adding, subtracting, multiplying, dividing, and the composition. So lots to take a look at on the homework assignment. Let your instructor know if you have any questions.